Hi everyone, today we're actually going to work with logs algebraically. I want you to pause the video, copy anything you see that's not on your note packet, and then come back so that we can continue. Alright, so it says use the formula to convert from log form to exponential form and vice versa. This is something that's very important. You have to memorize this. You're going to have to know how to go from an exponential to a log and then from a log to an exponential. So, take a look at 2 cubed equals 8. It's true, 2 cubed is 8. It's an exponential. If we want to take that exponential and write it as a log, we would do log of, who's my base in that exponential equation? 2. So, log of 2, who's the answer? 8 would equal 3. So, you actually have to know how to go forward and backwards. Log form of an equation. Both logarithmic and exponential functions give information about a power. All log equations can be written as an exponential form using the following rule. So we talked about it already, that you need to be able to go from an exponential to a log and now from a log to an exponential. So log base b of c equals a, which actually means b raised to the a power equals c. If an answer is given, then what you need to do is change the log to an exponential in order to solve. If no answer is given, then you need to use what we did on the last video, which is called change of base, and then put it in the calculator. Let's recall what change of base is. We're right over here now. Change of base would be, if you had log base 3 of x, you would write it as log of x divided by log of 3. All right, let's do number 1 together. Write log base 381 equals 4 in exponential form. Okay, so who's my base? 3. Who's my exponent? 4. Who's my answer? 81. Check this out on the calculator. Is 3 raised to the 4th power 81? Yes, it is. You're correct, which means we did it correctly. All right, number 2, write that exponential in log form. All right, so whenever time you're doing log form, you start with the word log. So log of base what? Who's my base in that exponential equation? You're correct is 8. Next comes the answer. Well, who's the answer in that equation? 64 equals, who's my exponent? 2. So I'm actually following the form of how to go from an exponential to a log. Again, the more you do it, the better it's going to get for you, but you have to memorize how to go forward and backwards. Okay, let's move on. Solve for x. Log base x of 8 equals 3. Well, this time they gave me an answer, so what I wrote above says if an answer is given, we want to change it to an exponential to solve. So we're going to write it as an exponential. So my base is x, my exponent is 3, and my answer is 8. Now we're going back to Unit 5. How do we solve for a base when an exponent is given? You're right, we're going to actually raise it to the reciprocal power. So we're going to raise both sides to the 1/3 power, which will give me x to the first on the left, which is plain old x, and 8 raised to the 1/3 power on the calculator is 2. So there's my answer. All right, find the value of log base 5 of 25. There is no answer here. So we're going to have to do what's called change of base. So it's going to be log of 25 divided by log of 5. Okay, we can now put this in our calculator. So take out your calculator and type in log. The log button is next to 7. Next to the number 7 on the calculator. Okay, so log 25 close parentheses divide by log 5 close parentheses, hit enter, and you get 2. So if there is no variable in the change of base, you can actually type it in the calculator and get your answer. All right, number 5. If f of x equals log base 8 of x, find f of 4. So f of 4 is going to be log of base 8 of 4. There is no answer, so we're going to do change of base. Log of 4 divided by log of 8. Put it in the calculator. Tell me what you get. Remember, if you get a decimal, always change it to a fraction. You're correct. It comes out to be 2/3. Okay, let's go on. Solve the following equations for x. All right, number 6, they gave us an answer. So we're going to change it to an exponential. My base is 6, my exponent is 2, my answer is x. What's 6 squared? You're right, so 36 equals x. Let's go on to number 9. They gave me an answer here, so I'm going to change it to an exponential. My base is x, my exponent is a half, my answer is 16. All right, I can't put that in the calculator. I want to get x by itself. You're right, I can raise it to the reciprocal power. Reciprocal of 1 over 2 is 2, so whatever I do to the left, I do to the right. So I'm going to end up with x to the first, which is x, and 16 squared is 256. All right, let's move on to number 10. X equals log 4 of 8. I don't have an answer. I mean, I do. It's actually x, so I really don't have it. I'm looking for it. So I can actually do change of base here. So I'm going to do log of 8 divided by log of 4. We'll do x equals. Plug it in the calculator. Log of 8, close parentheses, divided by log of 4, close parentheses, hit enter, and math fraction enter. X comes out to be 3/2. Number 11, log base x plus 1 of 64 equals 2. They gave me an answer, so I'm going to change it to an exponential. My base is x plus 1. My exponent is 2. My answer is 64. All right, we're down to an algebra problem. X plus 1 squared means x plus 1 times x plus 1 equals 64. So I'm going to have to do FOIL. First, outer, inner, last combined like terms. I'll get x squared plus 2x plus 1 equals 64. I've got a squaring, so I'm going to get one side equal to 0. I'm going to subtract 64 on both sides and get x squared plus 2x minus 63 equals 0. Let's factor in t-bar. Factors of a negative 63, that'll give me a positive 2 and add it. You're correct, plus 9 minus 7. So x is going to be a negative 9, and x is going to be a positive 7. So I have two answers. Okay. Let's plug it in and see what we've got. If we put negative 9 into x, negative 9 plus 1 is a negative 8. So it's log of negative 8 of 64 should be 2. Well, let's actually put that in the calculator as log of 64 divided by log of negative 8. So we're going to do change of base. Log of 64 divided by log of negative 8. And what happens? It says non-real answer, which means it can't be done. So you're going to actually reject the negative 9. All right, let's actually see if 7 works. So if we put 7 in for x, 7 plus 1 is 6. So we're going to do log of 64 divided by log of 6 into the calculator. Log of 64 divided by log of 6. And we end up with 2.321. Does it actually equal 2? Oh, wait a minute. My mistake. And I'm sure you're all sitting there going, what is she doing? It's not log of 6. If I put 7 in for x, 7 plus 1 is what, you guys? You're right. It's 8. So let's change that. Okay, now let's put in the calculator. Log of 64 divided by log of 8. And I'm sure many of you already did it and got it done, and you realize it is 2, so my answer does work for 7. Now, let's talk about why the negative 9 didn't work. When I actually put the negative into the x, I still got a negative answer. And when I put a log of a negative number in the calculator, it comes out to be an error. Do you remember on the last video we said that we're never going to have an x value that's less than 0? So with that being said, you're never going to be able to take the log of a negative number. So anytime you plug in a negative number and it makes you take the log of a negative number when checking, you're going to have to reject it because you can't take the log of a negative number. All right, let's go on to 13. Write an equation for the inverse of y equals 10 to the x minus 1. Well, inverse means to switch the x and y. X equals 10 to the y minus 1. But as we talked about in the last video, we can't solve for y when y is the exponent. So the only other thing we can do is change it to a log. So it's going to be log of base 10 of x equals y minus 1. Now, do you think I could get y by itself? Sure I can. It's going to be log base 10 of x plus 1 equals y. So as soon as I change it to a log, the y is no longer an exponent, and then I'm able to solve for y to get y by itself, to actually write the inverse. Okay, there were a few on this page that I skipped. I want you to try those on your own. Bring them to class tomorrow and we'll see how well you did.